Okay, so the quadratic equation, let's say you have x squared plus 2x plus 3 is equal to 0. If you want to solve for x, you can solve for x a few ways. So you can factor, you can use the quadratic formula, you can complete the square, and you can do another form of factoring known as the AC method. Now, there are more methods that you can use to solve quadratic equations, but these are like the most common ones. These are the only ones that I know and the only ones I use. So, basically, let's start off with factoring. So, well, first off, let's talk about what a quadratic equation is. So, if you remember in Algebra 1, they had y is equal to mx plus b. This is an equation that graphs a line. So x is the input, y is the output. So for every x input, there was a corresponding y output, and those two x inputs and y outputs together form one point, and then every other x input with the other corresponding y input forms another point. And if it's in the form, if the equation is in this form, y equals mx plus b, then it'll draw a line. It'll graph one straight line on a graph, on a Cartesian coordinate plane. And that's lines. That's linear. Now, in algebra, you can also graph a curve with an equation. So, the quadratic equation does graph a curve. It always graphs a parabola. Parabola is a U-shaped curve, like this. That's a parabola. That's what a quadratic equation graphs. It's a U-shaped curve, parabola. And the x values, for every x value there's a corresponding y value, and that forms one point. And every x value, every x input has a corresponding y output that also forms another point. And together, every input and output together forms this curve of the quadratic equation. So, let's say you have y is equal to x squared plus 3x plus 2. So if you set the output to 0, if you set y equals to 0, if you set this whole expression, or this whole equation equal to 0, you're finding every x input of the equation that exists along this x-axis, where y is equal to 0. So when y equals to 0, the x values of the curve is at the x-axis. It's on these 2 points right here. So you can see that this x-intercepts is what you're solving for. Whenever you set y equal to 0 or the equation equals 0 and solve for x, you're solving for the x-intercepts. It's the x value such that the curve has x values where y is equal to 0. And that's all you're doing. You're solving for the x-intercept. Whenever you set the equation equal to 0, you solve for the x-intercept. And that's very useful. I mean, you can use it in many math and science courses, and it's used all over the place. And you can solve for this using the common methods that I told you before. So let's talk about factoring an equation, factor a quadratic equation to solve for x. So if the quadratic equation is factorable, you can factor it. If it's not factorable, then you can't. You have to use some other method to solve for it. You can always use the quadratic formula. If you want to solve for x with a quadratic equation, you can always use the quadratic formula. But that method is a little bit tedious, so you might want to use other methods such as factoring or completing the square. So sometimes you can't complete the square to solve, or sometimes you can't factor to solve, so you have to use the quadratic formula. But I'm going to give you an equation that you can factor to solve. So let's say there's 2x, it's 2x squared minus 2x minus 24 is equal to 0. The first step you want to do is see if the whole thing is divisible by 2 or some, factor such that all the numbers can divide evenly. So in other words, if you was to divide this whole thing by 2, even the right side, you would get x squared minus x minus 12 is equal to 0. So the point of doing that is to get this first coefficient equal to 1. So if you can divide this whole equation right here by some number where every coefficient divides evenly and this first coefficient turns to 1, that's what you want to do first every time you try to solve for a quadratic equation. So I just did that. I divided it by 2 and the first coefficient is 1. That was the goal. Now we can factor it. So we want to find the factors of negative 12 that equal, when added together, equals negative 1. So in other words, let's find the factors of 12. They have 1 and 12, they have 2 and 6, and they have 3 and 4. That's all the factors of 12. And we know that negative 3 times positive 4 equals negative 12, but negative 3 plus positive 4 doesn't equal negative 1. But we do know that negative 4 times positive 3 equals negative 12, and negative 4 plus positive 3 equals negative 1. So that's the pair of factors that we want to use. So what we're trying to do is rewrite this in the form of a product of two binomials. So this right here can be written as x plus 3 times x minus 4. So this and this are the same thing. They're just rewritten versions of each other. And to show why, let me erase this to make more room. If you remember, when you have a product of two binomials, you can expand it or write it in a different form like this as a trinomial by foiling it. Remember the FOIL method, you get the first terms and you multiply them, you get the outer terms, multiply them, and you get the inner terms, and then you get the last terms. That's what FOIL stands for, first, outer, inner, last. So let's get the first terms, just to show you how this equals this, I'm going to use the FOIL method. So you get the first terms, x squared, plus the outer terms, negative 4x, plus the inner terms, plus 3x, plus the outer terms multiplied, which is negative 12. And then you combine like terms, you get x squared minus x minus 12. And look, whenever you FOIL this, you got this, which is this. So you can see that by foiling it, you can rewrite this as a product of two binomials. And by the way, the FOIL method, another way of looking at it is just double distribution. So if you remember the distributive property, let's say you have x times x plus 4, you can rewrite this using the distributive property where you multiply this and then add that to the multiplication product of this, which is going to be x squared plus 4x. So that's the distributive property, but the FOIL method is basically double distribution. So in other words, you get this times this, and you get this times this. That's, if you was to think about it, the FOIL method is that. It's the same exact thing as double distributing. It's a double distributive property. It's the same exact thing. So anyway, we've got this written as a product of two binomials. So we factored it. Now we have to solve for x. So we know that these two binomials multiplied by each other equals 0. So that means that x minus 4 must be 0 or x plus 3 must be 0. Actually, either case is true. When x plus 3 is some number, is equal to some number, and x minus 4 is equal to 0, this equals 0. So we know that x minus 4 in some cases must always be equal to 0, and in some cases x plus 3 must always be equal to 0. Because x plus 3 when it equals 0, multiplied by x minus 4 equals 0. Or in some cases, both of them are equal to 0. So we know that in some cases x plus 3 is equal to 0, and in some cases x minus 4 is equal to 0. So let's equate them to 0. So x plus 3 equals 0, and x minus 4 is equal to 0. So we should solve. X equals negative 3 and x equals 4. So the answer is x is equal to negative 3 or x is equal to 4. And that's how you solve a quadratic equation by factoring. Now let's talk about completing the square. So let's say we have the equation x squared minus 6x plus 3 is equal to 0. So the first coefficient is equal to 1. That's not necessary to complete the square by solving. And the middle term, the middle coefficient, is divisible by 2. So you can divide it evenly. So we can solve this quadratic equation by completing the square. Now let's do that. So the first step you want to do is subtract 3 from both sides. So that's going to turn out to be x squared minus 6x is equal to negative 3. Now we're going to get negative 6. Remember to include this negative sign. If the coefficient is negative, you include that negative sign. So we're going to get negative 6 and divide it by 2. So we get negative 3. Now we get negative 3 and square it. We get 9. That's the magic number. Remember this 9. I'm going to write it down right here, and I'm going to erase this to make room. So 9, remember that number. So what I did was I divided negative 6 by 2 and squared that result. So we got 9. Now what we're going to do is we're going to add 9 to both sides. We're going to get x squared minus 6 plus 9 is equal to negative 3 plus 9, which is 6. So you might be wondering, why did we divide negative 6 by 2 and then square that result? And then why did we add 9 to both sides? And why did we subtract negative 3 from both sides? You can go on YouTube and look up the proof behind completing the square. It just works. If you follow these steps, you can solve for the equation by completing the square. Now I'm not going to go too much into like showing the proof behind why completing the square works. You can look up proofs on YouTube. Just type in completing the square proof or why does it work. And they'll give you a very easy explanation. It's not that hard to understand. It really is. You can actually use actual squares to actually prove it. And that's that. So anyway, let's continue. So now we have x squared minus 6x plus 9 is equal to 6. So if you remember a couple steps before, we divided negative 6 by 2. So that's also a magic number. So negative 6 divided by 2 is equal to negative 3. This is the second magic number. So remember negative 3. So the next step is x, and then we're going to put some number right here, is equal to 6. So we have to have this form like this. X in parentheses squared with some number right here in the circle. What number goes in the circle is the number we just talked about. It's this magic number, negative 3. So we're going to put negative 3 right here. All we're doing is just getting negative 6 and divided by 2. And be sure to include the negative. So it's going to be negative 3. So the number we put in x, the x inside parentheses of the square is going to be negative 3. So x minus 3 squared is equal to 6. So this right here is just another way of writing this. Because, like I said with factoring, this right here is just a product of two binomials. It's x minus 3 times x minus 3. And if you FOIL this, you get this. So let me backspace. So now we're right here. What do we do from here? What we're going to do is we're going to try and get x minus 3 by itself. That way we can continue to solve the equation by rearranging. So x minus 3, to get it by itself, you're going to have to take the square root of both sides. So x minus 3 squared, taking the square root of that, is equal to x minus 3. In other words, let's say you have 4 squared. If you take the square root of 4 squared, you just get 4. You get what's underneath the radical symbol. Or if you have x squared, if you take the square root of x squared, you just get x. So the square root symbol and the square just cancel. So we get x minus 3 is equal to the square root of 6. But you have to be careful. Remember this. I try to always remember this. When you take the square root of a number, it's always equal to plus or minus that square root of the number. So if you take 4, the square root of 4, it's not only equal to 2, but it's also equal to negative 2. So in 5th grade, when you learn about square roots, and the teacher asks you what's the square root of 4, and you said 2, that's part of the right answer. It's always, always, always going to be plus or minus 2. It's positive 2 or negative 2. Always. Anytime you take the square root of any number, you have to try and always remember that. Because the square root of a number is just asking what two same numbers when multiplied by each other equals that number. So, in other words, the square root of 4, you're just asking what two numbers that are the same when multiplied by each other equals 4. It's going to be 2 and negative 2, because negative 2 times negative 2 equals 4, and positive 2 times positive 2 also equals 4. So always remember, it's plus or minus 2. Or plus or minus that number, square root of that number. So we have x minus 3 is equal to plus or minus square root of 6. Now, you could say, you put this in parentheses and this would be plus or minus also. And you could say that. But we just don't do that because really it's the same exact thing. I mean, whether you have this plus or minus on the outside of the parentheses, it turns out to be exactly the same whenever you work it out. So you don't need to do that. You just need to have plus or minus on this right here. And from there, we're going to add 3 to both sides. So we're going to get x is equal to 3 plus or minus the square root of 6. And we're done. We solved for this quadratic equation. So let me make more room here. The answer is x is equal to 3 plus the square root of 6, or x is equal to 3 minus the square root of 6. Either one is the right answer. Both are technically correct. So that's the answer. That's what x is equal to whenever y is equal to 0 for this quadratic equation. Now, let's talk about the AC method. AC method is another type of factoring. Like, let's say if you have a quadratic equation that's in this form. 4x squared plus 37, better 2 than that, plus 9 is equal to 0. So if we have 4x squared plus 37 plus 9 is equal to 0. Notice that the first coefficient is not equal to 1, it's equal to 4. And that if you were to divide the whole equation by some number to divide it evenly, it doesn't divide evenly. You can't divide 37 by any number to result in some even number. And same thing for 9. You can't divide 9 evenly. So what do we do here? We can use the quadratic formula, which I'm going to talk about in a little bit. But we're not going to do that. That's a little bit complicated. Instead, we can do something easier. We can factor by the AC method. So what you do is you get this coefficient and you get this coefficient and you multiply them by each other. So you get 9 times 4. That's going to be 36. Now, once we get the A and the C and multiply them by each other, we get 36. Now we have to write down every factor of 36. So we have 1 and 36. We have 2 and let's see, is it 16, I think? Or what's 36? It's 18. And let's see, 4 and 9. And I think I skipped 1. 3 and 12. Yeah, 3 and 12. So these are all the numbers, these are all the factors that multiply to get 36. Now that we have all of them written down, we have to figure out which pair of factors, when added together, equals this middle, and I forgot to put an x right here, which equals this middle coefficient. So, if we know that 1 plus 36 equals 37, we can use 1 and 36. So, let's do that. So let's rewrite this like this. 4x squared plus x plus 36x plus 9 is equal to 0. So notice that x plus 36x is equal to 37x. There's really a 1 that's written before this x. So if you combine the like terms, you get 36x plus x is equal to 37x. I'm just rewriting this like this. So from here, we're going to write parentheses around this binomial and this binomial. So what we're going to do is we're going to factor out as much as we can from each binomial. So we can factor out x from this binomial. So let's do that. We get x times 4x plus 1. And from this binomial, we can factor out 9. So we get 9 times 4x plus 1 is equal to 0. Now notice that as I did the AC method, this right here and this right here are equal. If you did the AC method and these two binomials turn out to not be equal, you did something wrong and you got to backtrack. But if you got them right, if you got them equal, you got it right. So from here, we're going to factor out 4x plus 1 from this expression. So we get 4x plus 1 multiplied by x plus 9. Essentially, this and this are the same thing, they're just rewritten forms, because 4x plus 1 is distributed to x and 9. So it's the same thing. And then we just set it equal to 0 and then solve for each binomial. And that's how you solve for a quadratic equation using the AC method. Now, you can't always use the AC method, you can't always factor, and you can't always use completing a square, but you can always use a quadratic formula. So let's do that. I'm going to give you an equation, a quadratic equation, where you solve it by using the quadratic formula. So let's write 3x squared minus 2x plus 1 is equal to 0. So this, I'm going to solve it by using the quadratic formula. So if a quadratic equation is written in the form ax squared plus bx plus c is equal to 0, we're going to set 3 is equal to a, b is equal to negative 2. Make sure you include that negative. If the coefficient is negative, you include that. And c is equal to 1. So this is c. So, to solve for x in this formula, in this equation, we use the quadratic formula. It's going to be in the form negative b plus or minus square root of b squared minus 4ac all divided by 2a. So that's the quadratic formula. It's just solving for x. Now, you can derive this formula using completing the square. I'm not going to get too much into deriving this formula or showing the proof for it. If you go on YouTube and type in derivation of the quadratic formula, it'll give you the proof as to how this formula is the formula you use to solve for x. And it is. You can look it up on YouTube. It's simple proof. Use completing the square. But now that we have a, b, and c, we just plug it into this formula and we can solve for x. We can solve for the x inside the quadratic equation. So let's do that. So x is equal to negative b. So in this case, b is already negative 2. So a negative is just a positive. So so the first thing is going to be 2. Plus or minus b squared. So that's negative 2 squared. It's going to be 4 minus 4 times 3 times 1. All over 2 times 3. So let's erase to make room. So, from here, we can simplify. So we have 2 plus or minus the square root of 4. So we're going to have negative 4 times 3 times 1, that's negative 12. And it looks like I have to use other numbers because this quadratic equation simplifies into an imaginary, it has an imaginary part to it, so you can't use this. So that means I'm going to have to make, let's see, I'm going to have to make 3 a negative. So let's make a right here a negative. So let's rewrite this. A is equal to negative 3, b is equal to negative 2, and c is equal to 1. So, you cannot use, whenever, see, like, this turned out to be a greater negative number than this positive number, which means they're going to be, this turns out to be a negative number. You can't take the square root of a negative number because no two of the same numbers multiplied by each other equals a negative number. It's just an imaginary number. So I'm going to use a different number. I'm going to use, instead of using 3 right here, I'm going to use negative 3. That way, these two things can add up to be a positive number. So, let me erase this. So we get, this is negative 3, so we get 2 plus or minus square root of 4 minus 4 times negative 3 times 1 all over 6, which is further 2 plus or minus square root of 4, and this is going to be 4 times 3, which is 12. So plus 12 over 6. So, let's further simplify this. Let's reduce it. 2 plus or minus 12 plus 4 is 16 over 6. And the square root of 16 is just 4. So we have 2 plus or minus 4 over 6. So from here, we're just going to rewrite this as 2 plus 4 over 6 and 2 minus 4 over 6. So x is equal to either one of these. So we have 2 plus 4 is 6, divided by 6 is just 1. And 2 minus 4 is negative 2, divided by 6 is going to be negative 1/3. Because that's negative 2 over 6, and then divide the top and the bottom by 2, that's going to be negative 1/3. So the answer is going to be x is equal to 1 or x is equal to negative 1/3. And that's how you solve for quadratic equations, use quadratic formula. And that's it.